This is a 3D modeling video for the Elegoo Mars Resin Tank Shelf. If you are not familiar with this project, click on the link on the top right, where I showed how I came up with the design. And hopefully this video is helpful for you to learn something about CAD or Fusion 360. So let's recreate the box itself. Create a sketch. Okay, and we just need to create a rectangle, and we already measured the width is 180 millimeters and the height is close to 125, and we can do a simple extrusion, and let's do 3. So that's one of the box. Let's name it before I do that, let's go back and let's do the extrusion again, and it's 33, but instead of a new body, let's make a new component and click OK. So that's gonna be our tank, because we're gonna duplicate it multiple times, and we'll use the pattern, so rectangular pattern. And I think we can do component, and let's do Z. Where's the direction? Let's pick this axis, and we're gonna do 4 of those. So something like that. We might need to add it out later because it depends on what kind of material we're gonna use. Okay, maybe it's important to draw out where the FEP films are. So let's do a quick measure on that. Let's do 12 for safe. So let's go back to the tank part and let's draw on here. I'm just gonna project this whole face. Oh, sorry. Project this whole face, then we can offset it, and we do the chain selection and make sure it's 12. So that's where the FEP film is, and that's definitely somewhere we don't want any contact with any parts. So maybe we just extrude out a little bit. I mean, in the real thing it's not, but this is just to illustrate. This is a piece that we don't want to mess up with. So all the components are updated. That's great. Save it. Line. Okay. Now we need to figure out the wall pieces. So maybe we start from the shelf. So the shelf, it's basically a U shape, since we already discussed these directions. Let's start from here and start a new component. So I'll call that bottom shelf, and we'll start on this and just sketch on that surface, since we already have it, everything here like drawn out. And as we mentioned, we want a one piece opening, so we can put it in without damaging the fab. So we can do extend. So what I just did was hitting S, which is a search, and you can type in the command you're looking for. But it's not letting me, which is okay. We'll just draw a line, and the T is to trim. Wait, why it's not letting me trim? Okay. We can delete this and not delete that. Okay. Now we should be able to extrude out that. That will be the layer that supports the whole thing. Okay. We also mentioned about the tabs. I think this might be a weak point, and maybe we add another one here and something on the back. So let's do that. We'll find the absolute center, draw a line, make it a reference. That's just our center line. And I'm just drawing L for drawing the line and X to make the line a reference. So you can select it in X, and, by toggling a different style. So what I'm trying to do now is draw a little tab. I'll just freehand it. It's just a tab. Maybe another one here. Oh, this thing is in the way. Okay, something like that. So I do want this get centered to this section. So how do I do that? Let's see. We can definitely find the center here, but we're not getting the center here because this is the center of the whole section. We can draw another line, then we could find the center here and connect the two centers. Give the reference, of course, then make that a vertical piece. That's this button. There you go. I know there's a excessive line here just for us to get the center, but I think it's okay. Okay, make sure that's a reference. And now we just need to define the size. I think this should be, I'll leave this here. I think this is hitting the D for dimension. 40 looks good, and I'll just make sure I can actually make them equal. So select both of them and equal. So we can just change this one dimension. So now we can mirror this back to this side, and we can add a same thing here. So this time I can just make this two selection and then make the midpoint. For some reason it goes on the other way, but that's fine. Let's make this 40 as well. And lastly is mirror. Let's just mirror this and this. Select the mirror line, and that's it. So why I left that open, that I'll come to that next. So as we started this extrusion, I didn't put any number in because I'm not sure what material or what thickness we're going to use. This also applies to you because we could have different stocks for different materials. So the thing for me to do it and to make the design more flexible is to add a parameter. So we can go modify and change parameter. We can have a user parameter here, and this would be the board thickness. It doesn't let you put any space in it. So let's see, that's like 3 millimeter. We can change this thing later. Board thickness. Okay, just need to remember that 3 millimeters. And okay, now I should have defined it before all the extrusion, so we don't have to come back here. But here we could type in board thickness, and that's going to be 3. And for all these tabs, if the side wall is going to be the same material, we don't want anything stick out too much. So that's how we do it here, board thickness. And let's make sure this is equal to that. I should have done this earlier. Okay. Now we can define this guy to that. I'm not very confident about the tabs, but yeah, it looks so tiny. We probably need to use some thicker material than that. Finish sketch, and also realize this is not selecting all the tabs. But I'll show you what I meant by that flexibility. Like right now, this is this 3mm thick, and the tabs are like that. Let's say if I got a 10mm board, I can just change it to 10, and watch what happens. So boom, everything is updated. Everything. So we are good to go. We probably can define the space in between the parts with this parameter, so that when we update the board, everything is updating too. So let's edit this out. So right now we are on extend. Maybe we should do spacing instead. So right now the spacing, I need to figure out how it works. So if that's 0 spacing, that's 5. Distance. Okay, I need to figure this out. So 33, let's see. 33 is the height of the tank. So that's exactly, they're like stacking on top of each other. So if we add a board thickness, then that would compensate our board. Maybe we add a little more, like 1 millimeter as an extra spacing for it to go in and out easier. All right, so that's it. And we could do another pattern. So create pattern, and we want it to be component, and the direction would be Z. And we can do spacing as well. So how many we need? Definitely more than 3, maybe 4. Yeah, 4 it's what we're talking about. So negative 33, I don't know why it is negative. And we need to minus this time board thickness, and plus 1 for the compensation or tolerance. And that looks pretty good. Okay, so now I don't think I'm gonna use anything like 10mm thick acrylics. So let's change it back to 3 and watch all the magic happen. Okay, there we go. We might need more spacing here, like I don't want this dragging through the side walls. It might be okay. I mean, because we measured the box a little bit bigger on purpose. Okay, now maybe it's time to do the back wall. So let's start from this face. Yes, let's start from there. Assembly, new component, and this is the back wall. Okay, and we're gonna start on this surface and bring in the, wait, where's my sketch button? Create sketch. Okay, so it's probably something bigger. What is this? Okay, all right, so the back wall, let's do a square. No, oh, because I just restarted it, all my preferences are gone. Okay, my favorite rectangle is the center rectangle, but it's not as default on the 2 panel. So what you can do is click the 3 dots and pin to 2 bar, and that's how you get it. So let's just do a box for now. And this is definitely going to match there. Yeah, I'm not sure if it could reference to that. It's not, but we can project it here. There you go. And that's definitely going there. And this definitely to be on the center line. I don't know where that is snapped into. So we probably draw a reference line again and make sure it's not following, but we can just make it a coincident here. Okay, so we can still go up and down. I think realistically this should be okay. We don't care about the top, right? I mean, it would bring extra strength, so we still need the top. So let's project that as well. So that's going to be one line. And let's make a measurement here and make that the board thickness. +1 maybe. Should be +1. So that we have the space for the top. And what we can do now is I actually want to get all these guys as well. Oh no. Oh shit, I forgot to hold shift. So if you are trying to select something like the stacking together, you can hold your left mouse button, and this pop-up menu is going to show up. So project. All right. So if we do an extrusion now, it should have all the CAD out, and we can include that little thing. And we're going to go this way. So that's negative for thickness. And there you go. So that's our back wall. Let's see how it looks. We also need to think how we connect those pieces. So I don't think the shelves need to be connected or anchored to anything. So the only thing at question is the side walls and top and bottom. And the bottom is already here, but that's not gonna hold up anything unless we glue it. In general, I'm not liking gluing anything. So we need to use the technique to fix acrylic pieces, which normally is a screw hole to a nut. So the nut will come here and screw to a nut, and the nut will be here. So currently our board 3mm are too thin for that kind of job. We don't want to complicate things by adding other parts. Like we can totally 3D print some brackets. That's not necessary. I think the problem to solve that is to make this up a little bit. So instead of it going on the bottom, actually there are more things on the bottom. So let's fix that. So we are not gonna let this guy clip or snap at here. Delete unnecessary lines. Select this guy and delete. And okay, maybe we just add a bunch here. That might be a little bit easier. So let's not snap into that. So we'll just do a collinear. Okay. Let's just add some 10 millimeter feet or step kind of thing on the bottom. Finish sketch. Wait, oh, okay, because we didn't select that piece. Okay, so we can literally drill screws to it. So let's get some screws here for reference. I think I'm gonna use M3 screws, which is pretty big. I mean, it's gonna be 3 millimeters, and the nuts will be a little bit bigger. So the nuts will get in the way. We're gonna build a sidewall, and before that, let's get some hardware. So what we can do is insert mcmaster-carr component, and you're gonna open this mcmaster-carr website, and we're gonna need some screws, and let's just pick some M3 screws. The style really doesn't matter. And you know, we don't really care about the other specs, material, whatever, but it's mainly for dimension. So we just need to grab the model. So I think we want an M3, and it could be fully threaded, and we can use like maybe 5 millimeters for now. Standard, that's all good. So here you can click this part number and the product detail, and on the bottom you can save it as a step file, and click save, and this part will be brought in your design, and we can do some adjustments. So okay, oh, maybe we should have something longer than 5 millimeters. Well, it's probably fine. Let's insert the nuts as well. Nuts, X nut, and that's good. Metric, and we want M3. So it should be pretty much the same, I think. So the width is 5.5. Yeah, should be the same kind. We'll just select the part number, product detail, step, save. There you go. Let me rotate it for the original position. All right. So the plan is to have a screw going in this way and have a nut on the other horizontal panel so they can be secured. And we're doing that because I mean, I don't want to glue it. And we'll start with an example, I guess. Here's another question. If we use a nut, then the sidewall won't be flush, because you need extra space for the screw hole. That won't be good. So either the front and the back wall need to grow bigger, or like this, the bottom is perfectly fine. So I'll just screws in, and the nuts will be hidden here. On the side, I really want the side to be flush. So how we do that? Maybe the whole thing is screwed to these shelves, so the out parameter can be flush. Okay, sorry, we were having some recording issues, so some of the steps are gone, but it is okay. I basically created another component as the side wall, and I'm trying to cut some slots. I don't like how it looks now, I have to tell you. Just looks weird. So we could drill a hole here and have the nut on the wall, then the wall won't be flush. You're gonna see like a half nut hanging out there, which is not good looking either. We could have a bigger top that overhangs the thing, and there might be little tabs that feed into the top so that they're interlocking each other. So maybe we should drill the holes from the side so the screw is exposed on the side and the nut is inside so nobody can see it. I think that could work. Let's edit the side wall. And if we can edit the drawing here, we could easily create rectangles from all this side. That's a face we want to project. Same that, that, and that. Okay. And now we can, since let me see, it's the first and the third. We'll just create a simple line here, and also between the third. And finish the sketch, and on the extrusion part we just need to select that and that, call it down. Wait, where's the back surface go? So something's wrong there. For some reason it's what? Okay. For some reason, something is messed up. Now you see that means something is overlapping. I don't know what's going on, because I was referencing the surface? No, I don't think so. Like, I don't know what happened there. The back wall is here. And the sketch is here. Oh, it's that line got break up part. Okay. You can fix that. So basically, when I change that face, and that was gone because of the references are gone. Now we can select the first one. I don't need that to be extruded. None of these. I need you, and I don't need you. I don't need you. Ooh. Okay. Something is very much messed up. Okay. Oh, what happened? Okay. Okay. Oh, so this was a cut for sure. Okay, I just need to select those two. That's all. And make sure I don't cut anything else. Okay, that looks better. And if we go back, that's what we meant to begin with. And now I need to drill a hole here. So it's back to this sidewall. And let's create a new sketch here. I mean, we could have, let's just use the same sketch. But I don't think we can reference that anymore. Then, okay, never mind. Create new sketch on here. And we need to take the reference of this whole thing here. So select P. That's the face we're talking about. That's face. Okay. So the reason why we need this is to find the center and draw a circle. So we know we're using M3, so let's put 3 there. But for you guys to make changes, if you have other kind of screws, let's say screw diameter, and that's 3 for here. But feel free to make it anything else. Okay. So that will be screw diameter. So we'll dig a hole there and also dig a hole here. Screw diameter. All right. And we might also need holes here. I'm not determined yet. Let's just start from here. And we probably need another one here too. Maybe that is more important than in the middle here. Or maybe we don't need any. Who knows? Let's start from simple maybe. The less screws the better. We're gonna have a top cover that should hold everything up. Maybe at least we need one for the bottom. Okay. Extrude. Whoa. Just need these 2 holes. Nothing else. Okay. And we can cut to negative bore thickness. And okay. And now we can pair, or should I say, create a joint. And that looks pretty good. So that definitely need to be a little bit longer. to go in here, and now we need to cut a hole to fit this nut. Let's measure how wide this nut is. So inspect, select the two surfaces. 5.5. Okay. So on this panel, we're back here. I seriously need this to be on the toolbar because that's what it was. So create another sketch, and since this is here, we can all have it line up, and we need a rectangle of 5.5 like height, and I think this was 2.4 or something, but let's do a 2.8. Also, we should make those parameters. So let's do that real quick. Nut width, let's do 5.5, and nut height 2.8. Okay, that will be nut height, and this will be nut width, and we can cut a hole here. That's negative bore thickness, and we make a cut, and that's the only thing we're cutting. Okay, cool. Then we can fit our nut in there. Okay, now we can put our nut on there, and we have to move it closer. Let's take a look here. So we can move this surface and this surface a joint. So now that's not what we wanted, so we have to rotate it. Let's see the angles. Okay, something like that. And we can move this a little bit forward. So that should do it. Okay. Why the knot has a little extension here? I'm not sure. So we might need to open this up a little bit more. Let's add it this sketch here. So knot width plus 0.2 and plus 0.2, and we need to open this up too. So let's do that. And we make this the screw B. And finish sketch. So give it a little tolerance here. And select that. Okay, so the screw, I know we picked the shorter one, but a longer one could work. Probably about 8 M3 by 8 millimeters should work great. So we're gonna have that here, 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 and here. And that should look pretty good. Other than that, we might want to add one over here. So the problem that the nut created is it extends out this little 120-degree angle here. so that in the inside behind the wall that gonna be a problem. So if we pick something thicker than this, let's see, let's change our parameter to like 5. Let's see how that looks. Border thickness, let's do 5. Okay. That got misaligned. Wonder why that happened. So it still extends out a little bit. Guess that the sketch is not getting the reference. So there's no reference to the center, so we have to do that here. I think we need to grab that as a projection and make that the center, so that should work forever. But even with a board that's thick, you are not solving that problem. So maybe we still go back to 3. I think that's lighter material, and make the whole thing lighter. Let's change to 3. Okay. All right. While we're at this, let's mirror this thing so it can work for other holes on the back. So we need to grab this guy here, project it, and we need to find a center line. Let's create a line here to here. I think it's getting that. Let's just make sure. Perfect. So we can draw a center line here for the mirroring. And also we can mirror the feature maybe. So S mirror this, 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 and this, and this. The mirror line would be here. Okay. And the sketch, edit feature, we're gonna pick this guy as well. And maybe before the joint, let's mirror. Wait, what? Mirror features, and we select the features. Mirror plane would be this. Okay, that's it. For some reason that is not okay. So we actually have to mirror a bunch of those. So edit feature, and we can just add this guy and also this guy. Okay, so that looks good. Our side wall and the back wall gonna be securely fastened. So the other question is adding some connection here and also the top. Also, meanwhile, there's a little problem, so we just need to project the face, and that's it. No, that's still not doing it. Oh, I don't care. Okay. It should be this whole thing. Okay, that looks good. So coming next, it's gonna be here, but as we mentioned, the nut gonna create a problem. Maybe we can offset it somehow, because we have room here. We can put the screw down a little bit and leave the nut not touching the surface. Or we have to grow the whole thing, make it wider, which is not favorable. If we can do four screws all the way, then maybe we don't have to do the top. The top is not needed anyway. And we just need something to hold the front. Maybe we should do that. It's just the nut issue. What if we go the other way around? That probably won't work well. Okay, so we skipped a couple of features. So let's go back a little bit, see what happened. I think last time we were here and added a little piece on the bottom to make it stand up and also connect the side walls. It's pretty straightforward. And now also adding the top, I added the tabs on the back wall and also on the side walls, so that we can have the top connect to all three walls, make sure they are holding up together. Also here, to make it stronger, I added another geometry here that to make this tab enclosed, so it won't come out or go back. Other than that, it's one thing I changed from last time. It was the tanks were exposed a little bit, like a ½ inch exposed, so we can pull it out. But I was thinking maybe that's gonna create a big gap for the light to leak through. So the idea here is to have a hole on the side and duplicate it to every tank, and also on the other side. So you can use this as a hole to pull the tank out initially, then you can pull it out from at the front. So all these sketches you've seen here, that's to get this geometry as a sketch, and also have a part called to cut, and you basically select a surface and create a sketch, and then you can export them as DXFs, which can be opened on your vector software and print on your laser printer or laser cutter. So hopefully this is helpful, and please leave any comment if you have any questions, and I'll try my best to reply. For more videos of me designing and making stuff, don't forget to subscribe, and I'll see you next time.